My name is John Siegel. I'm the president of the Granite State Woodturners. And the Granite State Woodturners is a subgroup of the Guild of New Hampshire Woodworkers, and it's also an official chapter of the American Association of Woodturners. Today is November 27th, 2004, and we're at the shop of Peter Block in New London, New Hampshire. And today we're going to have a discussion on sharpening wood-turning chisels. And there are four presenters today who are going to talk about their methods and different aspects of sharpening chisels. I'm going to be doing some of that. We'll also have Andy Motter, Michael Fonner, and Dick Batchelder. So all four of those people will be giving presentations today. One of the things about sharpening wood-turning chisels is that there are many different ways to do it, and there are many schools of thought, and there are many contradictory opinions about how it should be done. In fact, in the most recent issue of American Woodturner magazine, which is the journal of the American Association of Woodturners, there's this interesting article in defense of your favorite skew. This talks about different types of skew chisels. And we have Nick Cook and Alan Lacer here facing off, so to speak, in a little debate about which type of skew chisel is best. Well, this is the kind of discourse that we're going to try to promote today. And hopefully it will be an interchange and not necessarily discord or argument or debate. No one's really going to win, but everyone should get a chance to express their opinion. I think that there are two things to keep in mind here. One is that each one of us will try to present our way of doing it as the best way, because that's only natural. That makes sense to us. It must be the best way. On the other hand, I think we're all intelligent enough, everyone in this room is intelligent enough to know that all these other ways also work. And all you need to do is look at the wood turnings that are produced by the different wood turners who may use radically different methods of sharpening and radically different types of tools to get the results that they get. And they all obviously work. And so let's keep all that in mind, keep a totally open mind as we listen to different points of view, even when they contradict, and even when there seems to be kind of a head-to-head debate over this being better or that being better. I'm going to start by saying that I learned to sharpen after about 20 years of doing woodworking, and I thought I had a pretty good handle on sharpening tools. I really learned to sharpen in a grocery store. I was standing there at the meat counter, and they had one of these places where the butcher was working in a room that was glass, and I was watching the butcher working, and he really seemed to know what he was doing. And he was cutting, and then he had a sharpening tool with some kind of a stone or rod, and he did this, and then he cut for about 30 seconds, and then he did this, and then he cut for about 30 seconds. And after 1 minute that I watched him, he sharpened his knife 3 times. But I was amazed at how he incorporated the sharpening into the rhythm of his work. It was just a natural process. And as I left the store, I thought about how my own wood turning was a constant frustration over how short a time the tools stayed sharp, and how I didn't like interrupting my work. When I was getting ready to make that finished cut, I had to stop everything, turn everything off, go over somewhere else, change my whole mindset, my whole whatever, get the sharpening, then come back, and then I didn't know where I was. It took a long time to get back to where I was. So as I left the store, I vowed that I would try to be more like the butcher, to incorporate the sharpening into the rhythm of my work in a natural way, the way that he did. But in order to do that, I had to find a way to sharpen in seconds instead of minutes. And the way I finally got to that myself was the belt buff system, which we'll talk about at the end. Because at the end of this presentation, we're going to look at different sharpening jigs and methods, grinding wheels, belt buff systems, and torque system, and we'll talk about those different things right at the end. Well, my whole attitude about sharpening changed at that time as I was trying to develop a system that allowed me to sharpen chisels very quickly. And what I wanted was for the rhythm of my work to be dictated by the work, not by the chisel. In other words, if I was doing a certain process with a certain part of the turning, I wanted to complete that process. And I wanted the sharpening to be incorporated into that so that I could sharpen before my finish cut without, when you're working a certain shape and you're taking your cuts and you're getting near that finished cut, there's a certain muscle memory that you develop as you're working. And then you don't want to lose that muscle memory by going off and doing something different. So that was my attitude. And I started thinking about sharpening, and I came to this conclusion, what I call the sharpening axiom, which is simply to say, and I think Michael Farner told me, mentioned on the phone the other day in a way that expresses it best. And that is, sometimes people get confused and they think that the sharp chisel is the end product. They're forgetting that it's the wood turning that's the end product. So I really changed my mind about sharpening. Now this it's not to say that I don't respect someone who thinks of sharpening as an important ritual. I mean, if you look at for example, the Japanese woodworkers, there's this anecdote about the Japanese woodworkers that sharpen their plane after every stroke. Or you may say, well, that's obviously excessive. But on the other hand, that the Japanese woodworker who sharpens his plane after every stroke is on the right path in certain ways because he understands that sharpening, as much as possible, needs to be a continuous process. I don't believe that sharpening should be a ritual that you do at the beginning of the day, or the end of the day, or at the beginning of this project, or right after lunch. Sharpening should be a continuous process, something that you incorporate into the rhythm of your work. The next little story I have is about, let me just mention that those of us that have been turning for decades sometimes have trouble teaching beginners because we can't remember how we learned what we know. It was too long ago. Once a student asked me, how do you know when your chisel's done? And I said, well, when it's not cutting as well as it did before. And he said, oh, you don't understand my question. And I realized that what he was saying was that he didn't think he had ever experienced a sharp chisel, so my frame of reference was useless to him. In trying to express what a sharp chisel is, there's really nothing that I can do short of getting a microscope and looking at the edge, which I can't do, and probably you can't do either. What I can do, though, is I can try to talk about what is a sharp edge, what is a dull edge, and how do you know the difference. So if you've experienced these symptoms, you probably have a dull tool. Andy mentioned to me the other day about one of the best experiences that he feels he can give his students. And I know also when I teach students, when a student seems to be struggling, you go over there and say, what seems to be wrong? Say, let me see that chisel. And I do a little, oh, wait, this chisel needs to be sharpened. You say, oh, it does? Right, so you take the chisel over there, you sharpen it, you bring it back, and the student takes that chisel, and all of a sudden, he knows the difference. He feels that difference right now. And that's one of the most important lessons that you can teach a beginner about woodturning. If your chisel is dull, you will experience some of these symptoms. But all of these symptoms are comparative, aren't they? They say it's less good than a sharp chisel. Well, we know it's less good than a sharp chisel. But somehow, you need to identify what problems you're having. I'm speaking mostly to beginners here. You need to identify what problems you're having, and are some of these problems perhaps due to poor sharpening, or perhaps the need of sharpening. I guess you can read them. I don't need to read them. These are all on the handout also. Yes?
Would you read them? Some of us in the back there.
Fine. Okay, I'd be happy to. More force is required to keep the tool stable. That would mean your chisel is getting dull. A rougher surface is produced with more tear out. More dust and less shavings emerge from the tool. And more heat is produced, especially with dry wood. You may not notice this on wet wood. Does anyone have, I'm sure there are more things you could add to this list. When anyone wants to add more to this list, tell me. We can just put them right on there. Okay. So what happens when a chisel gets dull? Now, we don't really have a microscope that we can look at a chisel with, but here's a very simple upfront way to think about what happens. What is dullness? A sharp chisel, when it's truly sharp, comes to a point, and the width of the edge is 0 or near 0. We won't worry about very, very microscopic things. But depending on how fine of a grit that you used to sharpen the chisel, the two planes come together essentially in a line which is smooth and has no width. As you use the chisel, the abrasive quality of the wood starts to wear away at that point. And this is an enlarged view of the tip of the chisel. And what happens is first it rounds a little bit more, a little bit more. This is a steady, continuous process of wear. The chisel doesn't become dull all of a sudden. It starts out a little bit more and more and more and more. But at some point you have to decide, now I really have to stop and sharpen. And you'll get a feeling for that. Usually when the width, if you think of these are actually more hyperbolic than circular, but just for the sake of simplicity, I've drawn these as circles. When the diameter of that circle reaches about 1/1000th of an inch, that's when you really start to have trouble getting a nice cut. You may still use the chisel for roughing out purposes, but when you're talking about getting down to the fine cuts and really getting a smooth cut, anytime the width of this edge is more than 1/1000th of an inch, you're probably going to have trouble. So this leads us to what I call sharpening rule number 1, the most important sharpening rule, which is very short and sweet. This should be the cornerstone of your sharpening philosophy. It's the most important thing to know about sharpening. Remove the least amount of metal possible. Right? Well, if you're removing more than 1/1000th of an inch, then you're wasting time, you're wasting expensive metal, you're creating a lot of hazardous abrasive dust, and it's just simply unnecessary, usually, to remove more than 1/1000th of an inch of metal in order to renew the edge. This should be the cornerstone of your sharpening philosophy. Remove the minimum amount of metal. Now, how do you do this? There are a lot of different ways to accomplish the minimum. But here are some of the important things that I think you should know. When you're designing a sharpening system, one of the main things you're looking for is convenience. And convenience, may or may not translate into speed. But what it means is that you have a system that's foolproof, that's easy. In the case of the system that I use, I can look out the window while I'm sharpening my chisels, just like I look out the window while I'm washing my dishes. What's very important here is this word here, procrastination. One of the things that beginners always have trouble with, even intermediate turners always have trouble with, is what I call sharpening procrastination. Sharpening procrastination is a true evil. It's when you're turning and you say to myself, oh, I know I should sharpen this chisel now. I just don't want to stop because I'm right at this. That's not good. You shouldn't have those kinds of thoughts. Your sharpening system should be so convenient that it doesn't interrupt the rhythm of your work to sharpen. Then you will no longer have this problem of working with a chisel that's dull. Because the amount of time that it takes to bring it back to perfect sharpness is so short, the interruption is so short, that there's no reason not to just do it at any time. So this is a philosophy of sharpening. Now, how you actually accomplish removing 1/1000th of an inch of material quickly is that you have a system which allows for accuracy. This may be a system based on some kind of no-brainer mindless jig, or it could be a system based on the skill that you develop. But in any case, it has to be a system which allows you to take off the minimum amount says is repeatability is important in a sharpening system because this will prolong tool life. There again, removing the minimum amount of material prolongs tool life. Reduce sharpening time, therefore interrupting the rhythm of your work less. Reduce heat buildup, which, as you know, certain types of steel don't like to be overheated because it can change the crystal structure of the metal and make it hold an edge less well. And it satisfies rule number 1. So we're back to rule number 1, the cornerstone of the sharpening theory, which is remove the least amount of metal possible. So you can only remove the least amount of metal if you have accuracy. And now we need to get our arms around this subject, this whole business of sharpening. You know, I should mention that this, sharpening, has been the most requested topic by the Woodturners since I've been president for a year. So many people have come to me and said, when are we going to have a meeting on sharpening? I said, oh, well, we had one a few years ago. Well, did you tape it? Well, no, we didn't tape it. Well, we're taping it now. But the fact that so many people have asked for this topic means that we as a group, and I also think that there's been a failure in most of the literature on sharpening to really get their arms around this problem. And here's the way that I do it. I've divided this subject into 2 different areas that are completely different. If you look on the handout, you see there are 2 different flowcharts that show. I'm going to talk exactly about what I mean here in a minute. Tool point geometry and sharpening are 2 different subjects. So as we discussed today, we're going to be talking about 2 different subjects, which most books incorporate into one big confusing chapter called sharpening. But in fact, you really need 2 chapters, one called tool point geometry and another called sharpening. And the definitions. Tool point geometry describes the shape of the tool. To understand this topic thoroughly, we need to explore why the tool is shaped the way it is, and how the shape affects the way it behaves. And the most important word on this poster is the last word, behaves. In other words, we grind a tool to a certain shape because we want it to behave a certain way in this situation or that situation. If the tool is misbehaving, maybe we can correct, maybe it's us, but maybe we can correct that by changing the tool point geometry in some way. And by exploring different tool point geometries, we can see that the tool behaves differently in different situations. This is the crux of understanding tool point geometry, how the shape affects the behavior of the tool in our hand. Then, sharpening is the routine maintenance of the perfect edge. This assumes that the correct geometry has previously been achieved, and we aim to keep it that way as we sharpen the tool hundreds or even thousands of times. Now, it stands to reason that if you're only removing 1/1000th of an inch every time you sharpen, then you can get 3 or 4 or 5,000 sharpenings out of an ordinary chisel. So even if, like me, you may sharpen a chisel 50 times in one day, it will still last a long time. And once I got a good sharpening jig, I found out my chisels were no longer getting shorter. Well, they still get shorter, but I had chisels that I'd had for 30 years. And I turn every day. So these are the 2 definitions. And you understand why I feel these are separate areas. Okay. In my book, there'll be 2 separate chapters. And therefore, you need 2 separate sharpening systems. You You need one with a coarse grit for roughing out new or damaged tools to obtain the correct geometry, and one with a fine grit for routine maintenance of the edge. Now this latter sharpening system is the one that you rely on day by day, that you use over and over again as you're turning. But somewhere you have to have a way to rough out a chisel. Now that may be as simple as having a very coarse grinding wheel that you can use in those situations where you have dropped a chisel on the concrete floor, or you buy a used chisel from someone, or a chisel comes from the factory ground in a way that you don't like. And I should mention at this time that there's a myth that a lot of beginners believe that they should always try to maintain exactly the shape that the tool was when they bought it off the shelf, or that it was sent to them from the dealer. But you got to remember that the person who ground the chisel in the factory probably never turned a piece of wood in his life. So the idea that you should maintain the shape of the tool the way it came originally from the factory is a myth. You might leave it the same, but you should always try to decide what geometry do I want, and then you go to your course system and try to achieve that geometry. Yes.
What do you consider the coarse grits and fine grits for different sharpening systems?
Well,
whether it's a belt or a
in a belt, I think a coarse grit would be a 60. On a grinding wheel, I guess 60. Actually, I got to tell you, years ago I bought a 36 grit wheel for sharpening lawnmower blades, and now I use it for everything. Whenever I have to rough out a chisel, or a student brings me a chisel where the angles are all wrong, I go right up that 36 and it just eats up the metal. Then I go to my belt system and fix it. One of the beauties of the belt system is that it does both at the same time, because you can slip on a coarse belt or fine belt and you have the same setup.
So fine is 100, 120?
Oh, in a belt, 120, 150 would be the fine grit for maintenance of the edge. Peter's using 100 now. I've always used 150. So. What's a fine grit wheel?
I wouldn't go below 80, but I tend to like them a little bit coarse. I've seen people use 100 grit wheels.
Okay.
My preference is 60. 60 grit wheel and then home.
One of the most often asked, let me just point out a couple of things on tool point geometry that I think are important, and that'll be the end of my presentation. A couple of things. The most frequently asked question about tool point geometry is, what is the correct angle for the edge? Now, your cabinet making chisels and your carving chisel would probably ground at 25 to 30 degrees. And you may think that if that works for cabinet chisels, it's probably the right angle for wood turning chisels too. I disagree with that. I grind all of my chisels around 40 degrees, 35 to 40 degrees. So it's quite a bit more blunt than you would for a carving chisel or a cabinet making chisel. And the reason for that is several. Two reasons. One is that the conditions that a wood turning chisel are subjected to are much more brutal than the conditions that a carving tool, which is merely being pushed by hand, is subjected to. In other words, when the wood is moving past the chisel at 20 miles an hour for sustained periods, in just a few minutes, that chisel has traversed more wood than a carving chisel could in years. And therefore, you need an edge which is more durable. It has more substance to it. It has a little bit more blunt angle so that it can keep its sharpness longer and absorb heat better.
John?
Yeah.
When you say 30 degrees or whatever number of degrees, are you talking about off or flat of the tool, which means you have a 60-degree included angle?
No, I'm talking about the included angle.
Okay.
Right, and let me demonstrate that. The best way so we're talking about at this angle here. Okay, these are nice little protractors. And this is a great way to find out what the angle of the tool is. Just like that. Okay. Now, the reason that I believe in having a blunter angle is this. I like the way the tool behaves. Right? We're getting back to that. But there's something else. And that is that a carving chisel is almost always used to be pushed straight ahead. But a turning chisel is very often, and perhaps you might say most of the time, used at a shear angle. And the shear angle simply means that the chisel isn't moving this way, but it's the edge is at an angle to the direction of its travel. So what that produces is what's called an effective rake angle, an effective cutting angle, which is much less than the angle that you ground the chisel. Now to understand this concept, think about a switchback road going up a mountain. As you approach the mountain, the road starts to zigzag back and forth across the face of the mountain. And the reason it does that is because the effective incline is much less when you go diagonally to the slope rather than trying to go straight up the mountain. So this is exactly the concept that I'm talking about here. That as the chisel, I don't know if you can't see this. Instead of the chisel working this way, it's shearing this way. So the effective rake angle is much less. The peeling angle is much less because this is at an angle, just like a switchback road. So the effective cutting angle of the tool, even though it's grounded 40 degrees, the effective cutting angle of the tool may only be 25 or 30 degrees, when you're back to the angle that you would use, say, for a carving chisel. The next important thing on two-point geometry is nose radius. Now, we're talking here about gouges. Now, we can argue all day long about grinding flat, grinding hollow, side grinding, angles of grind, and all those different things. And all those things are important, but they're not as important as this. This factor determines more than any other how a gouge is going to behave. And I can pass this up. These are some wooden models of, if you take the same gouge, take your basic half-inch spindle gouge, sorry, half-inch spindle, because everybody has this. I'm trying to show with these models that there are many different ways that you can grind this edge. Let me pass those around. Those are models. But what I've drawn up here is exactly what you have there on those models. And what it shows are 5 different variations, which are simply in sequence, that show the different nose radius that's possible and how you get a completely different type of chisel. Now, this chisel is ground straight across, just like you would, say, a roughing gouge that you use in spindle turning. It's interesting to note that until recently, the English bowl turners always ground their bowl gouges straight across, believe it or not. But now there's all kinds of different grinds that are being used. But the difference between these gouges is simply that they've been ground to a different nose radius. The red circle is sort of the radius of the tip of the tool, which is the part of the tool that really doesn't work. And these tools will behave different ways in different situations. Now, most of the time, I grind my gouges either here or somewhere in between here or this. But you need to have some that are this way. You might even need to have some that are this way. So one gouge will not do everything. This is why I always tell people when they go to a yard sale and they find cheap, junky gouges, just buy them. You might think, oh, these must be really old and junky, but buy them because you can grind them different ways for special situations. You can experiment with them and find out just by trial and error what different grinds and different angles will do, and you might hesitate to do that on one of your very expensive gouges. The last thing I want to talk about just for a moment is metallurgy. At the moment that you purchase a tool, you're buying a tool made from a certain kind of metal. And until about 15 years ago, all turning chisels were made from carbon tool steel. And carbon tool steel is a stuff that's been almost unchanged for hundreds of years. Even though this high-speed steel was invented in 1930s, and by the end of World War II, it completely changed over machine shops and metalworking was done. They didn't come into common use in wood-turning shops until the 1980s for some reason. But now the standard tools are high-speed steel. Well, high-speed steel is simply steel with carbon steel with tungsten in it. It can withstand very high temperatures, and it's very hard. It's not harder than carbon steel, but it does have good abrasion resistance, which means it'll stay sharper for years. But now there are powdered metallurgy and all kinds of exotic high alloys, and you can spend a lot of money on chisels. All I want to say is that if you're looking for a chisel that will stay sharp forever, there ain't no such thing. Not even close. I think you'd be better off spending your time and your money on developing a good sharpening system. And that's all I have for you. Thank you very much. The next person who will do a presentation is Andy Motter. Andy teaches woodturning extensively at the Worcester School for Crafts, if I got the name right,
Yeah.
and also at the Homestead Woodworking School. And Andy will talk about his sharpening techniques. Take it away.
Okay, there's two basic subjects that John wanted me to cover today. One is sharpening freehand, because when you think about turning historically, that's the way the old timers did it. People talk about an Ellsworth grind or something. A lot of different Irish grinds used to be a term. Those were all done freehand. Somebody thought of a different geometry that they wanted to use in their tools, and they found a way to get there. Since then, people have developed jigs that help reproduce those grinds, but basically, freehand sharpening is the way everybody did it for many, 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 many years. So I'll just talk about, I think, probably spend a little bit more time on geometry and a little bit on sharpness. I think when we talk about sharpness, that's something that we all, everybody in this room, everybody on this panel can agree on. The sharpening is, the sharpness is the key to making our tools work. Where we get into differences is the shape of the tool, the geometry, how it works. And what I'll do is talk about a fairly simple system. I sort of believe in starting with where you are with what you've got. A fairly simple system. And just to illustrate that, this grinder was actually bought by my father many years ago. I'm still using it. This motor was an old one that was kicking around the house, again from my father's era. And that's quite a few years ago since he's been alive. And I found those things, and I found ways to make them work. Since then, I've added things, a small slipstone. I didn't have that. The regular bench sharpening stone for bench chisels, most people have that in their shop. So, this is kind of based on starting with what you have. Now, in terms of consistency and repeatability, there are a number of tools that I won't sharpen. And the skew chisel is notable among those. And what I do is I just set one rest on the grinder to the angle that I want the skew chisel. Just move it back and forth, move it back and forth. And again, as John pointed out, take off the minimum amount of steel. Then I hone it on a bench stone, just like you would a regular chisel. And then this old motor, I have my buffer, and I'll just buff that in a little bit, and I'm ready to go. So it's a fairly quick process. But the tools that I sharpen freehand are my gouges, spindle gouge, bowl gouge. And I do that because I like to sweep the edge around the side of the tool. So as opposed
Do you
to
wanna draw?
a drawing like this, let me, here's my model.
Do you wanna draw?
No, that's, I didn't extend the food all the way over. Get tired of carving. But what I've got here is an edge that's more, as you can see, more fingernail shaped. So that what I'm looking for is I can cut dead on like you would with a roughing. You're just trying to remove material. But to get that angle of cut that John was talking about, I can cut with these sides of the tool, and then I get a nice slicing action. And just to show you that, just imagine for a moment this is a long spindle, but you know this is that line that John was talking about, line of rotation, let's call it. So if I'm cutting with this side of the chisel, I've got my angle. Usually I find about 45 degrees works very nicely. I've got that angle for the rotation. If I cut with this side, I've got that angle for the line of rotation. So I can slice very nicely with either side of this tool. I don't have to swing the handle around very much. I can just kind of come right in and do a cove very nicely with that. I can roll it around and do a bead very nicely. And I can swing around to closer to the tip and just still try to keep that angle. But to me, that angle gives me the cleanest cut. It's what Frank Payne referred to as cutting wood the way it likes to be cut. I think it just peels right off of there. It slices very nicely. So I'm always looking for that with whatever tool I'm using. Same thing with the bowl gouge. If I'm cutting, actually, I'll tend to use the tip on the bowl gouge to get my finishing cut. And I'll rotate it over like this, so that actually where this tip is, a bigger one, the actual edge is at about 45 degrees to this line. Or I'll roll it over this way. And again, you're at about 45 degrees to that line. So that to me is my smoothest cut. If I'm removing a lot, if I've just turned the bowl around and I want to remove a lot of material from the face, I may actually use this part of the gouge, just kind of like a roughing gouge. I'll lay it up against there, just roll it over until the edge contacts, and it'll peel off big shavings. And that's what Ellsworth does with this gouge. That's what that's famous for. And that's the reason to sweep it back a little bit. Otherwise, most of the cutting that you do, you can do with a tip, and that's going to be your best finishing cut. So those are my reasons, very quickly. Let me know if that's not clear to you, but those are my reasons for wanting this sort of a little bit broader fingernail as opposed to more of a point like this, because I want to be able to cut on this side. Now, I mean, this gouge would work, or cut on this side. I want to be able to use those sides as well, and by sweeping this edge back, it allows me to be able to do that. So let me talk a little bit about grinding technique in order to, okay, how do you get that edge? How do you get that stuff back? Now this is a grinding wheel, it's no longer a turning. I'll lay the tool like this, just bring it up, and as the sparks begin to hit the edge, that tells me that I'm starting to get I'm working on that edge. So I do that, and I rotate it, and as I rotate, I move the tool forward. Some people will actually swing the handle around and can do that as well. I find just moving it up the wheel, it gives me a nice edge, just following that. And I believe that sharpening freehand is really something that any of us can do, and many of you probably do. It's the same finesse that we use on the lathe to get a good cut. It's that gentleness of approach, just taking the tool right in there. The same thing on the grinder. The only difference is you use your finger on the tool rest instead of, you never want your finger on the tool rest if you're cutting. But you put your finger on there and then just feel that edge. And it's that finesse of the tool and the edge to that round cylindrical piece, whether it's a grinding wheel or a turning, that is going to give you that nice edge. And it's going to give you a nice turning. So the finesse you develop sharpening helps with the finesse that you need to develop for turning. The finesse that you develop for turning helps you with the finesse that you need for sharpening. The sharper you get your tools, the better your finesse work. So it just, they feed each other. It goes back and forth.
I think you just said something significant, I think, that most of us wouldn't think of doing, putting your finger on the tool rest while you're grinding.
Yeah.
That's really important.
Okay, thank you. Yeah, that is,
Why do you do that?
that gives me,
Sensation?
that's a good question.
Why don't you go ahead and grind?
No, I'm sorry.
You do a grind.
You get some sort of sensory feedback.
Yeah, there's something
I'm a
about,
novice.
no, it is,
As you know, I took the course with you.
John said earlier, you know, a lot of times we haven't thought about why we do something. And, you got me on that one. It does, you know, I don't know, I think, oh, I feel like, you know, it just, it gives me a better sense of control. For that, so, you know, one of the best works if you can see it. But I'll just turn on the grinder, put my finger on the tool mount, find the edge. I just take a light little bit off of there. The other thing I do is I tend to break this corner that's left. I'll just kind of hit it quickly like that. Just helps the gaps behave better on the inside of the bowl.
What corner is it?
What's that?
What corner did you take?
This bottom corner, see where?
The heel.
Yeah. So if you, this right here. In other words, if you're particular on a wheel, you tend to get a little bit of a hollow, so this tends to be fairly sharp. So I just break that off, ease that a little bit, so that as you're coming around on the inside of the bowl, it's not, you know, doing anything as you're rubbing that metal, it's not tearing out the wood or whatever. It just makes it a little more controllable. I've seen some turners that will actually take a bowl gouge and they'll have one for the inside and one for the outside, and they'll actually radius this a little bit. And that'll work. That'll work nicely inside. That's about the only place. I tend to avoid, that's another point that we could probably make. What did you do for your angle, your tool angle skill? Was that the first? Tool angle?
First page of that one you saw.
First page.
That was, this one is future.
Yeah, no, I was looking at the first page of your files when you start to find the sharp point.
Oh, yeah, well, that wasn't a particular angle, it was just, you can go back to that if you want.
Okay, so this bevel is helping you to control the tool. The saying is, the bevel controls the cut, you control the bevel. And to the extent that you can use that, that saves you a lot of trouble and hassle in turning. So if you, for example, round this edge or this is no longer flat, so that maybe you have a micro bevel here, or this is a little bit rounded, it becomes very hard to find that bevel, and therefore it's very hard to control the tool. So having this flat, or even a little bit hollow ground, and then honed so that it's flat, really makes the tool much more controllable. And I would agree with John, it's how the tool behaves that you're after. So that's why when I first saw John's sharpening sanding jig system, I thought, wow, this is really great. It's so fast, it's so nice. And then I couldn't get the geometry that I liked. And I thought, well, okay, I could use this, and we have one at Homestead, we use it for the roughing gouges, for the skew chisels, for a lot of the things that are fairly standard. But I still, I have to do the spindle gouge or the bowl gouge the way I like it. And I found with the Ellsworth jig or the Wolverine jig, I can certainly reproduce the grind that I like. And, that's another way to do it. The other thing John wanted me to talk about, and I'll try to do this very quickly before we end up here, is scrapers. And in my mind, there's no, yes.
Before you go to scrapers, do you do spindle or bowl gouges any differently in terms of your technique? Do you still
Same technique.
sweep them back on the
Yeah.
spindle as well?
Yeah. I should pass around. That's pretty much an example.
So, let's plug all those little plugs right behind there. Yeah. I'm plugging them.
Okay, in my mind, there's no excuse for using a dull scraper. There's no excuse for using any dull tool, but scraper in particular. It's the easiest tool in the shop to sharpen, even with my system. I just set one tool rest for scrapers, scraper on there, over around, just to show you an example. That's it, you have a sharp scraper. The grinding wheel leaves a little burr on there. The burr does the cutting. I understand there's been some discussion in this group about burrs, and in thinking about it, I think there's probably three different approaches to a burr on a scraper that you could use. And one would be the one that I just showed you, the burr right off the grinder. The second would be do that, then hone it, and take a burnisher, something like this, made by Veritas, just put it in a vise, angle the tool against that, and you raise, after you clean that grinder burr off, you raise another burr, and it takes a little muscle, but high-speed steel, you've got to work at it a little bit. But you can get a nice burr with that. And I found if I'm having difficulty with a piece of wood, that I will actually maybe do that. Take off the old burr and put that other burr on there. I find that's a little bit sharper. Most of the time the burr right off the grinder works. The other possibility is just hone that burr right off of there and just have a nice sharp edge on your scraper. And that will still work. I've had students that have come and didn't know the quote-unquote correct way to sharpen a scraper, so they honed everything nice. And they got that scraper real sharp, and yeah, it works. It does the job as well. So I think probably the point I'd like to make is that sharpening for all of us is an individual thing. It's going to be what works for us. And I would suggest with the scrapers that you experiment with all three of those burrs. Find out what works best for you, what's convenient. Like I say, the quick and easy thing is to just put that with a grinder and go back to work. But if you're having some trouble, I think probably any of those other two burrs might be a little bit sharper, a little bit, just a little bit cleaner cut. Yes?
Because of the magic of videotape and DVDs, I can see a lot of extras. Very much the air letters, the things, but I was watching Jimmy Clues's tape, and he said it makes sense to him to turn the grinder, the breaker, bottom side up.
Yeah.
So that the burr comes off, and I haven't done it, but most of the time I've got two grinders going before it's set.
Mm-hmm.
It kind of makes sense to me, because that wheel's going this way, and the bottom's here, and the burr comes up,
the thing I've always thought about, I have metal tool rests, so as I swing that tool around, I'm gonna be taking that burr off as I rub it against this metal. And I've gotten a good enough result from the burr going the other way that I haven't felt the need to try that. I know a number of people that do that. And I think it depends on how you use the scraper and what you want to do it for. My use of the scraper is really a modification of the cabinet scraper. I use that angle and I just kind of slice wood off of that very lightly. So it's a between cutting and sanding kind of finishing technique. And if I can get a really good cut with a small radius gouge, like a 3/8 or 1/4 inch ball gouge, then I don't even need to scrape. Yes, sir.
How important is the amount of the angle of the angle?
On the scraper?
And what do you, any preference there?
Well, yeah, this is roughly my preference. Generally out of the box, they're a little bit blunter, and I've seen people use them a little bit sharper. I think it's all of those work. This is a little bit, if you're in a finer radius, this heel is a little bit relieved. If it was too blunt, you might end up not being able to cut. But we could measure what that angle is, but
It's just the idea that it's not that important.
it's not an absolute. Yeah.
Gouges are more important by the angle.
Yeah. And
Wouldn't just one approach, and then the approach to scraper.
for the scraper. Okay, well, it's just to the workpiece. Okay, that would be for sharpening. Okay, now for the workpiece, I'll tend to try to be below center. For the outside, I'll try to be below center, and again, I angle the tool. So some people refer to that as a shear scrape. I call it a finishing scrape because I like that analogy to the cabinet scraper. Shearing to me is when you take something like this and you shear it off, which to me it sounds more like traditional scraping, where you just put it on the tool rest and let it shear those fibers. But on that angle, you're actually kind of slicing a little bit more, and you're actually getting a more of a finishing cut. On the inside, assuming maybe one of these lines is the inside of the piece, I would want to be a little bit above center. Now the reasoning there is outside. If I'm above center and this digs in, it's going to want to walk right into that piece, whereas here it doesn't have that tendency. It's going to fall away. Same thing inside. I have that tendency where it's going to fall away from the piece, but below center, it's going to want to dig right in. You can have a real nice catch with a scraper below center on the inside.
On the interior of the bowl, you would have those.
Yes.
Maybe. The only thing I'm going to add about getting a burr on a scraper is that what works on one scraper might not work on another one. In other words, small differences in the metallurgy of the scraper might change the way the burr is formed on the grindstone. And where you may have success with a certain kind of grinder on one tool, you might need to burnish one. Another tool with a slightly different metallurgy may react differently. So you need to experiment and see, what works best.
And I think in adding to that, the burr off of a grinder is faceted by the wheel, and when you burnish it, it's a finer. And so one reason might be getting it better.
Yeah.
It'll hold up longer.
Yeah. So when I have difficulty, I'll go to that finer cut.
But in response to that, the old saying, if the little's good, a lot's better? That does not apply to burr. I know many beginners who have come to me and said, I had so much trouble with my scrapers until I figured out that I had too much burr. If you have too much burr, you're going to have trouble. So there's just exactly the right amount that works best.
So I think probably we're at a point where I should sum up. I think what I'd like to get across is I have experienced in the past myself, with students, I'm very fussy about sharpening. And try as I might, I haven't found any alternative. You get that tool sharp, it really works. So that sharp edge is really what you're striving for. There's lots of ways to get there. We're all individuals. There's probably as many different ways as there are people in the room. There are slight variations on different ways in terms of getting that sharp edge. But understand what that edge is, find a way that works for you. And I think the other thing I believe is that all of us could sharpen freehand. If you can turn, you can sharpen freehand. And that way, if you want to experiment with another shape, with another geometry on your chisel, don't be afraid to give it a try. And thank you very much.
We're gonna take 60 seconds to continue our discussion on sharpening wood-turning chisels. Michael Fauner, who is a full-time wood turner from Ware, New Hampshire, will talk to you next.
Well, like it or not, I seem to have developed a reputation for liking to play with one particular tool on a skew. And for some reason, over the last couple of decades or so, I developed a real fascination for the tool, only because it's really the spindle turner's final finish tool, and it's probably the best tool that the spindle turner has in his arsenal for giving a really fine burnished look to the piece. Gouges are wonderful things. They do roughing really well. They can do codes really well. Certain aspects of gouges are irreplaceable. But when it comes to certain cuts, only a skew can really do it. There's two basic shapes of skews. The English, which is basically straight across. I have a version of it here. Basically, it's just a straight across bevel, beveled on two sides. And the English tend to, for some odd reason, do everything straight. They do their gouges straight, they do their skews straight, and who knows why. But when it comes to the English, the Americanized version, we tend to do things on the skew anyway. So all of our skews are just that. They are skews. But there's a reason for that particular shape. Right? That shape provides good clearing angle for the ship, provides an unobstructed view of the cutting surface, as well as the very edge of the tool, and it provides it's more adaptable to a variety of cuts. In other words, the number of cuts that you can accomplish with that particular angle is much more beneficial than with a straight chisel. The angle is generally on most Americanized skews is considered to be about 70 degrees. Above or beyond that can cause some issues that comes down to handling characteristics that you may or may not like. Tends to cause insufficient clearing. The viewing angle gets messed up, and makes the tool a little bit more, shall we say, fixy. The second avenue of the shape has little to do with the skewed angle, but has more to do with the bevel. And the amount of bevel, I recall seeing something from Alan Lacer. He likes to use a bevel from the very edge to the back of about 1.5 times the thickness of the chisel. So if we take, if we have a 3/8 thick chisel, obviously we're going to wind up with a bevel that's considerably more than that. While some people tend to use an angle of about 12.5 degrees, that seems to be another common variation. But the commonality isn't isn't as important as what works for you with a particular type of wood you're using, as well as the type of cuts you're making. We've seen very, very, very steep angles, where you may have a bevel that comes way down here. There are some advantages to that, and there's a lot of disadvantages to that
Like about 12.5 degrees on each side,
on each side.
so that's a total of 25.
Right. So generally speaking, one of the advantages to having a long angle on each side is that you can have a better shearing cut, and it's like if you were to take a log and spin a log, what's going to give you the best shearing cut after cutting a piece of veneer, a piece that you take a log and you shear it in an angle like this, or if you shear it like this. Right? The more bevel you have rubbing, the better your chances of getting a nice veneer that comes off with a decent surface finish. So having a nice sheer cut and a longer bevel is an advantage. The disadvantage, obviously, is because you're spinning it so many revolutions per minute that your chances of drawing temper out of that metal becomes more likely. You'll tend to glue that tool the thinner you make it. You also have some stability problems with metal. The thinner it gets, the less vibration it can handle. So those are some of the disadvantages. I've seen people that have very short angles, shorter than 12.5, or shorter than an inch, 1.5 times the metal. And what they tend to get is their cuts tend not to be as shear worthy. In other words, they're almost doing a scraping motion of the pieces, and you tend not to get a smooth finish on the piece. What you'll often have is beads that won't roll well when you roll the skew to do a decent bead. Whether you use, everybody knows what these 2 points are: the toe and the heel. Often, and sometimes they're called the long point, the short point. And you can roll a bead with either heel or toe. I've heard people say, well, it only has to be with a short point, because you wind up getting a finer burnish on the bead by rolling it with the heel. The disadvantage is you don't get to see how you're turning that piece if you use the heel. So there's some advantages and disadvantages to using either method.
Any comment about turn edge, so that the heel is further back than the straight line is here?
Well,
You want to show me the one?
yeah, actually, we can kind of cut that out. All right, one of the things that we're talking about here is we've already kind of touched on these angles, but we've also, I was going to touch on this a little later on, but we'll touch on it now. But we can also get into radius angles in terms of geometry. That's something that you want to play with at some point in time. You may not want to do it until you feel like you've mastered the skew, because if you haven't mastered the skew with it being straight, you're not going to master it with it being curved. There's no inherent difference there. If you feel like you're real skittish when you go to turn that bead, whether you have a curve on it or not matters one way or the other. Right? So once you feel fairly proficient at using that tool, then you can play with lots of other geometry. But I tend to be one of those people that I like the more conventional. I mean, it's been around several hundred years. There's probably a reason for that. Right? So I tend to go with a more traditional approach for skews, because it works. And anything you want to do after that, after you feel like you've mastered that tool, great. These are some of the tools I use every day. I mean, I've got a radius tool that, you know, but I would only radius make this tool geometry like this if I were using a 1-inch or larger skew in terms of an ovalized skew. We've seen this type of, when you're using this type of shape, when you get down in width, it tends to flex a little bit, tends to move a little bit, not nearly as stable as a nice thick piece of metal will do. So my only caution in terms of an ovalized skew. John alluded to the article in the American Association of Woodturners. A rectangular skew versus ovalized. There's advantages and disadvantages to both. Unfortunately, that's the way in everything. In all the tools that you're about to see, there's advantages and disadvantages. Why would you use one over the other? I tend to use both. I tend to use this because, frankly, I got it cheap. Who cares? I mean, it's one of the things that I think a lot of woodturners get caught up on. One thing that people get caught up a lot on is, you know, the latest, greatest gadget. All right, for turning. I'm sorry, but in my book, it's still this and a lathe. You know, it's just a simple tool. And people forget that this is just a hunk of metal. That's all it is. And until you consider that, well, it's $100. I don't want to take off a whole lot of metal. You know, if you consider it just a hunk of metal, you get along a lot better in turning because you'll remove less material, as John has alluded to. You'll also not be scared of this stupid thing. You can change geometry, you can change things. It's just a hunk of metal. And if you can buy a tool pretty cheap and you can put a decent edge on it, you know, all the metallurgy in the world doesn't matter because you're going to be sharpening the thing many times over. I've got two ovalized. You can tell how much I use this. I mean, I think it's probably still got some of the original edge on the thing. I don't use it very much because I don't have that many straight cylinders that I do on a constant basis, or I'm not doing a lot of really large beads where, you know, I have a 2-inch bead that I'm doing very often. Usually my beads are limited to, you know, about an inch and a quarter in size and in height. So I don't usually need an inch and a quarter skew. So where you tend to use an awful lot, it's half-inch and half-inch, quarter, and 3/8 skews because you tend to roll a huge number of those beads. In terms of, you know, just regular rectangular bar stock. And you can buy the stock cheap about any place. It doesn't need to be grandiose $100 skews. And you see a lot of rolled edges and rounded edges. They're nice, and yes, they may roll across your tool, you know, your tool guide real easily. But if you put a little bit of wax on your, you know, you're not worried about it. But if you take just a tiny bit of wax on your tool glide, it does just that. It glides. The tool glides over the piece.
So, Michael, would we agree that it's not good to have a very sharp edge like the first picture?
Well, the majority of sharp edges that you see, that's the majority of these first skews. Almost all older skews all had sharp edges. And as long as you don't spend a lot of time catching with a skew, it shouldn't be a factor.
Right? You've got those slightly rounded. A lot of skews out of the box, that edge is actually sharp.
Right.
Use it as a scraper.
Exactly.
And that you want to get rid of.
And one of the things that Andy and John have both talked about in terms of skews is, does this need to be absolutely sharp. Of course not. You know, what I often do with mine is I'll take a piece of sandpaper and I'll go over all four corners and just lightly, you know, lightly take off the very, very sharpness of that corner. Only because if you do catch it, it's gonna, you know, if you've got a cast iron, you know, tool rest, it's gonna dig a little bit. Where if you softened it a tad, it won't be as much of a factor. But a lot of people tend to get catches because they tend to try to take off too much material at one time, rather than using the tool for the way it was meant to be used, and that's taking off very small amounts of wood. Because it's really a finish tool. It's really the final tool you use before you sand. And in some cases, you may not need to sand very much if you use your tool correctly. This tool isn't much different than using a gouge. Believe it or not, it really isn't, because you're still rubbing the bevel. Your tool is still moving across, and the tool rest. You do everything you do with a gouge. The only thing is, it's got a different look to it. And people that are scared of this tool, you know, they tend to have a death grip on it. And those are the ones that, and you know who you are. You know, if you have a death grip, man, you know, nothing goes worse in life than having, you know, being like this when you turn. You can't relax out of your mind if you don't do it. But you know, if you're taking small amounts and you're keeping that bevel rubbing, handle down, bevel rubbing, it's not a big factor. I'm seeing some people kind of gloss over it when I'm talking about this, what I'm talking about sharpening.
Michael, I see that your gouge chisels have a wide variety of angles. The one you're holding now, hold that up so we can see the angle.
If we look at
No,
this,
not that. Hold it this way.
if we look at this versus
Versus this.
I mean, there's obviously quite a difference in a bevel there.
So we use that.
But in terms of bevel, one of the things I tend to use is
Keep talking.
all right, one of the things I tend to use with bevels is when I'm doing an awful lot of beads, or if I'm doing very hard wood, I'll tend to use a bevel that is not nearly as sharp. That's what we've seen here in the past. The sharpness of that bevel will tend to cause some problems with extremely dense hardwood, because it tends to want to draw that temper out. And I'll want to, the more metal you have at the point where you're making contact with wood, the more you have a chance for that heat to dissipate. So the less material you present to the wood, the more you're going to build up heat, and the more you're going to draw out temper.
This one's 25 and this one's 65.
See,
They all work.
you can see major differences, but it also has to do with if I kept the bevel the same on every single one, I wouldn't be able to use it in different ways. So the ways that the wood that you're using and the types of cuts that you're making really dictate what bevel you have.
Do you have any preference in terms of the include the angle of the bevel, 25, 65, in terms of hitting beads?
Well, that again comes down to the type of wood you're using, right? And
Is it the type of wood, or is it also?
quite often it's type of wood, and it's and the reason I say that is because you get into some woods that are extremely dense and extremely hard, where the bevel, if your bevel is very long, right, we'd have some trouble again with, as you roll that bead and rubbing that bevel, you tend to overheat the tool.
Well, if you,
versus
if you
shorter, versus
discount
shorter.
the overheating for a second, just look at the ergonomics of it. The amount of bevel you have has a lot of effect on how much you need to swing the tool to create a certain shape. Can you comment on that a little bit?
Well, I haven't seen that, I haven't seen that that's been as much of a factor if I'm doing a bead. Generally, you're going to start here and end over here on the side. You're going to start on the side and roll vertical. So you're basically doing this regardless of where you are in turning a bead.
Aren't you also swinging the handle to keep the bevel rubbing as you come around?
Right, you are, but you're also moving the tool along the tool rest as well. Right, so as you're doing this type of motion. So the amount of angle you have isn't as important as perhaps the contact you're making with the wood. You know what I'm saying?
Like, how much of an issue really is worrying about drawing the temper, since probably most of us are using tools made of high-speed steel rather than carbon
It's not as
steel.
much of a factor, not as much of a factor as carbon steel. I tend to use, I still have a lot of old carbon steel. I don't be here and stuff. It's been lasting for the last 24, 25 years for me. So but you want to have, I mean, you're spending a very small amount of time grinding these tools compared to some gouges. I mean, I use a couple of different methods. One is just regular 6-inch grinding stone. But the one advantage that I have is I also use a jig with that grinding wheel. Make my own jig, basically just a board with whole board in it with a V jig, the base. And if I have a gouge of whatever size gouge I'm using, I can drop that in and have it instantly. If I'm sharpening skews on the other hand, I have a flat plate. I have a flat plate that gives me the same effect that Andy was using before, in that I can draw across here once, flip it, draw across the other way, and I'm done. Don't have to mess with anything. The angle's already set, and it's done for me. Where if I'm doing this type of skew, it's more freehand work. Right? Again, usually what I'll do is draw it in this fashion. So I'm using my hand just like I'm using, if I'm on the lathe. So it's the same type of effect, that type of motion.
Usually my beads tend to end up smaller than the original intended. I think the bottom of the cut somehow affected, made a spiral from the bead.
Right.
But I've got a very nice, long bevel on the steel or something. Would I do better if I use that 12 1/2? Do you think that would cause me less to fix that? It's a little off subject in terms of sharpening. Yeah.
But one of the things that might help you with that is if you design where you're going to have those beads, the outer edges, start by making a line on both sides. That gives you an end point. That's what when I'll teach a class, that's what I'll usually say to people is find where you're going to start and where you're going to end the bead, and roll to that. And you'll find that when you have a stopping place for it, if you're removing a small amount of material, I'm not even a factor anymore, because it automatically knows where to stop. But do you have any other sharpening type questions? Yeah. No. And now, granted, Andy does a lot of honing, and I applaud him for that. But I spend so much time at the lathe, and I spend so much time sharpening. All I want to do is zip, and I'm done. I'm on the lathe because I don't want to take the time to mess with it, because I can sharpen so quickly, so fast, and I'm back to work. I don't want to lose my train of thought with where I'm at, because I know that all I have to do is that, and I'm done. And I'll be back to it.
What good finish do you use?
I use about 100, I believe. It's some deep wheels.
A fine enough finish, but still have a really
Yeah.
good finish.
Yeah, the wheels are just fine enough that I don't wind up really deep. you know, we're really deep scratching.
What do you feel on the 6 tool as compared to the 8-inch wheel? I know it would be the less concave.
Well, again, we're getting into another area, concave versus flat, okay? And that's an element we can kind of touch on as we kind of finish up things. But frankly, I've never thought concave versus flat make a heck of a lot of difference. You're grinding off the tip so quickly, it really doesn't matter because you're going to go right back to sharpening anyway.
Okay, we're gonna move to the next topic. Thank you, Michael. Sorry we didn't have time for all the questions. I'm gonna go on to the next subject. You're all ready? Yes. All right, the next presenter is Dick Batchelder. And Dick is equally at home turning tiny things on the lathe as he is timber framing houses. I always say Dick's the most versatile woodworker I know. And he's going to talk about side grind gouges, specifically what's called the Ellsworth gouge.
Well, I guess today I'd like to just take and get rid of the mystery on the Irish grind of a swept back grind. I think a lot of it is that people see a grind like this, and I have a drawing here that kind of shows a big area of cutting surface. And the first time, just to tell you a story, the first time I ever had an opportunity to use this grind, I was at a workshop with David Ellsworth, and he didn't give us a choice. He just handed us a chisel and said, let's go to work. And in 3 days, it took 3 days to fully understand the geometry of the tool and how it behaved. And David spent a great deal of time talking about how you present the tool to the work, you know, to try to understand the behavior. I think behavior is what makes you either a wood turner or not. I mean, you become frustrated very quickly if the tool that you're using, you put to the work and it jumps back at you, or it takes a chunk of wood out and you have to start all over. You want to present the piece of, you know, a tool to the piece of work and have some results, you know, that are positive. Make you feel you're going in one direction. And I guess, to me, whatever grind I'm using, you know, it has to have 3 things that it achieves for me. You know, it has to have, going back to John's rules of sharpening, it has to have repeatability, and it has to have removing the least amount of material. And then you're going to be able to predict behavior. So all of those things, to me, are real important. And it's one reason I've chosen this grind to do probably all my bowl turning now. I use just 1 gouge. Now, John may use 5 gouges to do the same bowl. I think I'm 15 seconds ahead of him because I've got 1 gouge. And I'll tell you a little bit why. I'll explain to you why this gouge does the work of 4 of John's. You look at the amount of cutting surface I have. I sharpen my gouge. Takes the same amount of time as John, maybe a moment or 2 longer. John's bowl gouge has a cutting edge of half the amount. Now, that means John's going to the grinder twice as many times in a day as I am using this grind. Because I have the entire surface I can work. I can work, you know, from this point all the way down through. Every inch or every little bit of this edge has incredible cutting abilities. But you have to understand the behavior of it again. You have to understand how it is presented to the wood and how it actually cuts. Now this tool actually has the ability to do an outside cutting as well as the inside of a bowl. Now, the inside of a bowl, I mean, you look at a regular gouge. I'm just going to be using a spindle gouge, but just to show you that, you have the angle that you have here and the angle you have here allows this gouge to get to the bottom, partway to the bottom of a bowl. And then you have to stop because you can't maneuver the tool handle to get across the bottom. Whereas this tool here, if put into a bowl, you can actually roll this right through, and it's still, this handle is always clear of the outer rim of the bowl. And it's a remarkable tool in that respect, in that it allows you to do the work of several tools. Has the ability to do scraping. Just by the way it's presented to the tool, just present the very edge of the tool to do a shear scrape. And if you remember how Andy had talked about how he presents his scrapers, at a 45-degree angle. It's a shear scrape. This tool here, if this is the edge of the bowl, I can present this tool at 45 degrees. And I'm not even rubbing on the bevel. I'm just using the actual edge. And I can get the finest of shadings coming off of this tool. And so you're getting as fine a finish cut. And it is a finishing cut, but I'm going to refer to it as shear scraping because that's what the tool is doing. That's how it works. As it is coming across here.
Which proves that a scraper doesn't need a broom.
Exactly. It does not need a broom. So that is one reason I use it. I think another thing that John had brought up earlier was the dullness and to understand what is the difference between sharp and dull. And he said it very clearly. If you are working to make a tool cut, it's dull. If you're getting just dust off of the piece, it's dull. I mean, in order to be successful at turning, you've got to understand when the tool is dull. And it's a hard thing because I think as a beginner, many students come in there and they're already nervous. They're gripping a tool so that it won't take off on them. A sharp tool can present it to a piece of wood with one hand and effectively cut. But it's understanding how the tool behaves. And this is a really it's a tool that's apt to misbehave. Just in the amount of cutting angle. There's a lot of cutting edge to catch. So to understand how it is presented to the work is important. And that is actually, we're talking a little bit now, we're talking about the tool point geometry, or the shape of the tool. I think a lot of people have a hard time with this grind because they have a very difficult time understanding what shape it is actually supposed to be. So we're going to call this is what you want. This is the desired grind here. And I'm going to point out two of the most common problems with this grind. This is what you want. You want to be able to hold that tool right straight out in front of you, and this edge right here they need to be parallel with each other. You need to be able to look across there and see both sides just in a perfect arc. And it needs to be arced, or the intent is to have it arced here. And that gives you controllability. As soon as you start to cut this down, here's an example of this is like an overground edge. And I have an example here that I'm going to pass on that somebody brought in. This person is having trouble just getting the grind so you can use it. And that's very, very common. And that over grinding on that. The other common place where this grind becomes real difficult for people is over grinding the tip. And he also brought in one that he's been working on here. The tip is not, he hasn't even created the conical shape, which John's diagram showed very clearly. because this shape is very similar to the geometry that John had showed in all of his drawings. You know, but those, you can keep in mind this is what you want. And if you have any, if you want a really good teaching tool for this, David Ellsworth sells a video. Unfortunately, he's plugging his type of gouge and his sharpening jig, we can call it. But the video itself explains very, very well the whole process of achieving that and the importance of the shape. And he gives you, you know, examples of how, you know, in talking tool point geometry, how the shape of this bar, as well as the fluted area inside, how they relate to each other. His grind, I mean, his gouge itself has a very, very, it's not a really, it's got a very hollow area in the fluted area. And I know many people have come up to me with glazier gouges and tried to grind them in a fingernail. And the glazier gouge has a much more sharp radius in the bottom of the gouge. And it can be made into, you know, I wouldn't call it an Ellsworth grind. It's what I call it just a swept back grind. And very similar to Andy's. It's not Andy's because it's not freehand. It's made with a jig. And to me, jig's important. So I don't want to take the time at this point to learn how to do it freehand. I find the jig works for me. And I just prefer to do it that. I'd rather spend the time being comfortable turning and less time sharpening. Because I've tried to sharpen Andy's way, and I find it it's frustrating trying to get the shape that he's able to achieve without even thinking. I watch Andy sharpen, and I can't make the tool the shape that he's coming up with. And I also I understand this grind a little better, but it's from using it over the years. So that's the reasons I use this type of grind. And, I think it meets all of John's rules, perhaps except for rule number 5. And I want to make sure that, you know, I think those rules that John has mentioned here apply to all the sharpening. Any type of sharpening that is done on any type of tool. The relationship, the tool point geometry, and understanding how the overall shape of the tool so affects how it cuts. And the sharpening. And I hope when John does his book that he has tool point geometry before he does the sharpening chart. Because I think you have to understand what you want for desired shape. And then understand what is sharp and what is dull on that. And also to help kind of take the mystery out of the Irish grind. And the Irish grind, to be honest with you, it's just a term for that shape. Ellsworth does it slightly different than the Irish. The original Irish grind I saw was actually multi-bevel. It had a micro bevel on the back side of it, so that it was actually more aggressive because you had to, there were 2 bevels you had to deal with there, so it was just a little bit different. But I did want to take just a little time. I wanted to explain to you how one can come up with the desired shape. And I think that's one of the hardest things for people to actually understand. And I'm using an 8-inch grinding wheel as an example here.
If you have 2 of these, I'll pass one around.
Yeah, you can pass that around. There's 3 measurements that you need to really remember on this. Using an 8-inch wheel, you want to be setting the block where your tool post that say goes in, the jig post fits in, needs to be located at or approximately at 4 inches from the center of the wheel. So now, I brought in, and Andy has one as well, a sliding type of adjustment or jigs with a block already fastened onto it. So that, keeping that in mind, that's very important. And the next thing important, just the distance from the block to the face of the wheel needs to be 7 inches. Now what that does is that makes these fixed points. Now the next variable is the distance that the tool protrudes beyond the jig. Now, when I learned from David Ellsworth, his focus was just 2 inches away from it. And John and I have had some discussions in the past. Because is this length very important? I think in David's case, he's always done it this way. So that was the way I learned. Was this rod, the 5.5-inch rod, at 45 degrees off of this block coming down. But John and I had taken the measurement that really matters here is actually the distance from this point to here. Because as you push this forward and bring this back, it changes the angle that you're ending up with out here. And David's angle, I believe this was 65 degrees. And it doesn't have to be 65 degrees. Actually, this is exactly 65 degrees. It can be anywhere, 5 to 10 degrees in either direction, but it still will function. Sometimes what you'll find is that angle will be dictated to some degree by the inside shape of the gouge, and that goes back to tool point geometry, and understanding that whatever shape you're putting out here is so affected by the inside shape. So keeping that in mind, the desired shape is really what you're trying to come up with here. Keeping that edge swept back, but not concave. It needs to be convex. And keeping the point a nice radius and not undercut. So, and this, when one sharpens this, it takes no longer for me to sharpen this than it takes John to sharpen his.
Ooh.
But are you including the time it takes to put the jig on?
Which jig on?
Well, we'll do that after. We're going to do that.
And just to kind of wrap this up a little bit, there's a lot of jigs and stuff out there today. When I first learned this particular drawing, there was David's jig only. There was a couple of other sharpening systems, and I know there are some that have been brought in today to kind of show what's out there. But I was actually just looking through the Woodturners catalog, and I made a list of 6 entirely different sharpening systems, and they all do approximately the same thing, and they range from $30 to hundreds of dollars. So it's really coming up with a sharpening system that works well for you.
I have a question on the geometry of it.
Sure.
8-inch diameter wheel with your 4-inch radius, yet you've got a 4-inch dimension that drops down from the center.
Yeah, that's the location of where this post hits the block.
But it would actually be at the bottom of the wheel, which is 4-inch.
Well, with the edge, I didn't draw. Let's see. That was just for, I didn't make this to scale, so.
Steve, can I draw on your drawing?
You may draw on my drawing.
Was it 6-inch wheel, would you still have the 7 and 4?
Yes. You still have to have those dimensions. And what those dimensions do, they give you an area to work within. Now, John and I spent some time.
What we found out is that none of these measurements matter. What matters is this angle. And that this angle is actually a continuum. It could be 0 which is a regular grind, or it increases more and more and more, and the more you increase that angle, the more you have a side grind. But it is a continuum. So there is no actual distinction saying, oh, this is a side grind, or this, because this angle could be 3 degrees and then you have an ambiguous grind. Or it'll be in between.
But just to add on to that, if you take a look at one way's jig, that's exactly what they've done with their jig. They've managed to take this and make this totally adjustable, so that your geometry at the tip can change at any time at whatever angle you choose, because not all exact angles are the same for every turn.
But you can get the same effect by moving this up or down or cutting off the rod. So all these things really contribute to one thing, which is this angle.
And I think once you reach the desired shape, and this was a trick that David Ellsworth left with us, said, okay, he ground it the first time. He said, now, if you want to make sure you get that grind each time, he just takes the magic marker and just covers that grind.
So if you're adding this to your tongue,
It's a very quick thing. It's just a little trick, because I know people have trouble, even once they have the grind done right, they leave, go home, they get to the point where they have to sharpen it, all of a sudden it doesn't work. Something isn't right with it. And and what he does is he says, now do that. You can adjust this in and out. Don't mess with the adjustment there. But what you want to do is you want to get to the point where you just rub it against the wheel. It removes the magic marker right across the entire long surface.
David is pretty passionate about using the crown tool for the geometry. And you alluded to that, but I think you skipped over it for beginners. Some tools will not give you an Ellsworth grind and will only present the problems that you described. So some people need, despite everything they may have written down, to understand that the tool geometry is what you have to start with. And maybe it's for sales purposes, but it really does work.
Yeah, well, it absolutely is correct here, but I've actually been able to adapt this glacier gouge to Ellsworth school and come up with a swept back grind. I'm not even going to call it, this is an Ellsworth grind because it's an Ellsworth gouge. The Irish grind and the swept back grind is kind of generalized to other geometries.
We're going to move on. What we're going to do is save about 10 minutes now to do actual demonstrations of different sharpening systems. So are there any more quick questions for Dick?
This one is the 60-degree grind that gives you a lot of trouble in terms of the inside of the bowl. Rather than 45, you make that turn.
Whatever grind works for you. I mean, 65 is what works on the Ellsworth gouge. I've never used it with any other angle on it, but I'm sure other angles do work. Sure, DJ.
Make it say, we try to do a side grind on a random gouge. In order to get the proper shape of the edge, the ingredient is to turn it over, flip down on the grind. You grind that sweep first, and then turn it over to bring your bevel up to that edge that's produced.
It defeats rule number one of repeatability.
But that would be initially the first
Yes.
time.
Yeah.
Just a quick comment. I agree with Ellsworth school. About 7 cases, whatever they are. 2 on the grind. You still don't know, looking at the tapes and everybody, so he stands over the shoulder and says, I want to bevel this way. So here. And that's when you learn the grind is, and you can do that. But you can do it off of a one-way gouge. I've got a wood cut and I've got the jig, and I made some smaller jigs to fit the smaller jig. Unless you know what you're looking for, because he'll say, take a little more, this, a little more on the wing. You just don't get the same grind. You got straight grind.
I think that goes back into that what the desired shape is.
Even with this jig, you'll get it flat unless you know what you're doing off the tip and off the wing. As an amateur, but I learned that because I'm not an amateur.
Well, I think what David did say is the time you spend grinding on the edges is much greater than whatever you spend on the tip. And you grind the edges separately and then blend the tip into the wings.
camera here for a moment, and we're gonna set up some grinding systems and just take a few minutes with each one to actually see the process that's involved and the differences between. So let's do that. Now we're going to have 4 short demonstrations of different sharpening jigs and techniques. And the first person is Andy Motter, who will show us how he sharpens gouges freehand.
Okay, what I'm gonna do is sharpen a half-inch ball gouge. Apologize for those of you who went back. Yes, I have to view the camera. Fingers on the breath, touch the wall lightly, find the spot, hold the tool,